Now, another use for differentiation is to look at our functions or our gradient functions, and from that plot or to draw a function. So that's what we're going to do here. So we're looking at a gradient function. Now, formally you can't use any differentiation, but the concept's the same in that we're looking at a derivative function or a derivative graph, and then we're trying to turn that into an original graph or to the graph of the function. So let's have a look at this. So we've got this parabola here. Now, what I've done, I've broken up sections of this graph. So between negative infinity and negative 2, between negative 2 and 4, and between 4 and infinity. And then also what happens at x equals negative 2 and at x equals 4. That should be a 4, not a negative 4. So I'll fix that up. Let's cross that out and make that a 4. So now, the gradient. Remember, this here is the gradient function. So from negative infinity to negative 2, so everything from negative 2 to the left, our gradient function is what? It's above the x-axis, so that tells us that it is positive. Now, between negative 2 and 4, our gradient function is below the x-axis, so that tells us that it is negative. And then from 4 to infinity, so from everywhere from 4 onwards, once again our graph is positive. Now at x equals 2 and at x equals 4, we have x-intercepts. So our gradient equals 0 at those points. What happens when the gradient equals 0? We have stationary points. So we got turning points or points of inflection. So what we're going to do, I'm going to put down at negative 2 and then at 4. Just to know that's where we're working with. So between negative infinity and 2, it's positive. So we're going to go something positive. It's all about there. That's our x equals negative 2 and our x equals 4. Now, between negative 2 and 4, it is negative, so it's going to go down until it reaches there. So we've got a negative gradient. Then from 4 onwards, it is positive. So that's what we're doing there. It doesn't have to be perfect, doesn't have to be exact, but your function must reflect what's going on here. So, turning points, where it's got intercepts, where it's above the x-axis, we want a positive gradient. Where it's below the x-axis, we want a negative gradient. And that's what we're seeing happening there.